I've got an hour to talk to you. Myself and Ashley I'm from the Embed team at ARM. Ashley's with the sort of research group at the Vodafone developer department. If you could just ignore them for a bit, pay no attention to the nerds in the corner. So our talk today is about cloud connectivity for microcontrollers and connecting embedded systems to the internet. But to give you a bit of context of why we're here, I'm going to put a shameless plug in place. We've been working with the guys from Vodafone. As I say, we're from ARM. We do the microcontroller that you see there. And we've been working with the Vodafone guys for the last 6 months or so to try and enable microcontroller technology in the cloud. And we're doing this by using 3G USB technology and making that accessible. As of today, we have a beta program that we're opening up so users can get access to the code base. I've very subtly put the URL there. If you're interested in taking part in that beta trial, you can go there and sign up, so please don't be shy. For the duration of this presentation, we'll be using one of the little demos that we hacked together when it works. The idea is to show how an SMS system might be used for instant feedback. So if you text your questions to that number, we'll read them off at the end. It's basically just text into a thermal printer. Right, to give you a bit of context about the Embed platform, which is the microcontroller we've enabled, I'll go back a few years and give you an idea of some of the research we did. So the reason we are investing in this rapid prototyping platform is because there was lots of changes in the world of microcontrollers. So traditionally, the dominant cost of microcontrollers has been the amount of logic inside it, the amount of gates. These days, as process technology has shrunk, actually the dominating cost is the size of the flash memory and the RAM. So now for any microcontroller of a given memory configuration, actually the nature of its architecture is neither here nor there. And the good news from that is you can now get 32-bit Cortex-M3 microcontrollers for around about $1. So all of a sudden this sort of quite powerful technology competes with the older 8-bit and 16-bit technologies that dominated for so long. Secondly, microcontrollers are getting quite powerful nowadays. The particular one that we're using, all-in-one package, has all the things you'd expect in a microcontroller: digital interfaces, serial interfaces, analog interfaces. But you also find things like Ethernet, USB host, USB device, CAN, I2S, all these sort of high-level media interfaces. And they're all in the same package. You've got lots of memory in there, so half a mega flash, 64Ks of SRAM. And these are all the parts that are just $1 or so. So all of a sudden your bill of materials can include parts that have high-level functionality and quite a lot of processing power. And of course this means they're interactive as well. So now that you have USB in a microcontroller, applications that plug straight into a computer, or Ethernet gives you applications that go straight onto the cloud. And we think that gives lots of opportunities for microcontrollers in the future. When we looked at people designing with microcontrollers, we saw that there was a bit of a disconnect, really. The industry hadn't changed in a long time. It was quite old and fusty and out of date. So when we did a bit of research, we saw what had happened in other industries. So if you take 3D printing, 2D design, web frameworks, people don't put up with long time scales or long development cycles. There's this notion of rapid prototyping. So you can print a 3D model of something, you can knock up something in a CAD package and print it out, or you can even build a web application very quickly by using a rapid prototyping platform. So we set out to do exactly the same for microcontrollers. So the Embed platform is a developer website to support our platform, an online compiler, so this is the tools for writing your code, all hosted in the cloud. Think webmail, but web compiler, the same sort of idea. And we've also put a lot of work into high-level peripheral APIs, so this is abstracting away the complexities of the silicon devices and making them more intuitive and easier for people to use and apply to their own problems. And it's all wrapped up in a lovely little prototyping form factor that you can breadboard with, thus. So, because I'm a sucker for punishment, I've decided the best way to show you guys how easy it is to use this stuff is to do a very quick sort of live demo. First thing about the Embed microcontroller is when you plug it into your PC by USB, you get a USB flash drive appear. And this is how you interact with the device. It means it's driverless, it runs under Linux, Windows, Mac, you're not bound to any one particular platform. All the tools are hosted in the cloud, so we find ourselves going off to the internet to register, and this is where I hope our internet connection is held. Now, as it happens, I already have an account for Embed, you'll not be surprised to know. But the idea is to get people going as quickly as possible. If someone has a quick win, they'll invest more time. So straight away, we would have registered by now. It's just a case of putting in a couple of details and hitting register, and this is the landing page. So the first thing I would do as a new Embed user would be to download a program just to flash an LED, my Hello World program, prove I'm in control. So I download that, I save it straight to my Embed microcontroller's flash disk. See a little light flashing as it downloads. And very, very quickly I can press the go button and I'm now flashing an LED. Brilliant. Not particularly exciting, but it kind of proves the point that very, very quickly you can do something that would traditionally take quite some time. So that's the registration process. In terms of actually using an online compiler, it's fairly simple again. It's linked from our main website, as you can see there, with a big subtle red arrow. So once I've got my account registered, I can go straight to the online compiler and can start create my own programs. So there's a few in there which we'll be using shortly. But I can just say, give myself a new program. By default, we'll just get the same blinky program that we've just run. We're at the mercy of our Wi-Fi connection at the moment. If people are concerned about online tools, yes, this isn't ideal. We're obviously at an event where the Wi-Fi is being hammered, but you don't have to worry. If you don't want to use the online tools, you don't have to. We're not trying to lock people into any one particular platform. Any program that you create on the online tools, you can just as easily take offline and use under GCC or any other compiler of choice. I'm going to give it another 20 seconds, then give up, I think. Right, so by default I get a nice little simple program which I can compile. I'm assuming that goes quickly, yep. I can save that to my Embed flash device, press the go button, and hopefully I'm now flashing the other LED. Brilliant. Again, not particularly exciting, but I'm just trying to show you the ease of the use of the tools. Now the actual compiler on the back end is RVCT 4.1. It's the same compiler that's in all ARM's professional tools. All we've really done is put it on a web server and provided a very clean, sort of simple cut-down IDE to it. I'm very aware I don't want to get too far off topic. So that's us getting started. Now, a lot of the work we've done with Embed is trying to make it easy for people to experiment and prototype with ideas that they have. So I just want to show you how easy it might be to wire up some kind of sensor. So the one I'm going to use for this example is a temperature controller. So most embedded applications that use microcontrollers are really interfacing with the real world. It's about sensing, actuation, communication, that sort of thing. So the temperature controller we're using is a little I2C device. I don't know how many of you, show of hands quickly, how many people are software orientated here? Hardware happy and friendly? Okay, seems about right. So this is just a little I2C temperature sensor. I2C isn't the nicest of protocols, but we've done a lot of work to try and make that easier. So here is a code snippet of how we would talk to this sensor. We've provided very, very high level object orientation. So we have an object of type temperature sensor. We tell it which pins on the Embed to hook up to, and then we can just spin in a while one loop to make it work. Now, because the Wi-Fi is being a bit slow, I'm going to use one I made earlier in true Blue Peter style. So this is the basically the program that I just showed you from the slides. You can see basically what it does. I can compile that, download it to my Embed, and then very quickly that program is now running, hopefully. But you don't have to take my word for it. What we're doing here is print F in, and everyone wonders where stood out is going. So it just so happens for our microcontroller, because we've already got a USB connection, we might as well make the most of it and connect ourselves with a serial port. Right, great. So again, not particularly exciting, but very, very quickly you can see how you might have gone from wiring up a few wires, using some very, very high-level abstractions to actually sort of sensing some real-time data. And if I put my finger on it, it should, pop it as appropriate. So just to go back to the slides. Right, so that's how to get going with something as mundane. But what about communication? So imagine my temperature sensing application is an industrial or commercial greenhouse. So as with most embedded applications of this nature, there's going to be some kind of actuation or feedback. So I might have a temperature sensor driving a servo motor, and as it gets hotter and hotter in my greenhouse, I open some ducting. Well, that's great. But then what happens if the temperature carries on going up even when the ducts are fully open? You know, what do I do then? Well, it's at that point that a closed-loop control system really needs to become a communication-based system. So obviously the solution to that is introduce some kind of communication. Now, in a greenhouse scenario, you might not have Wi-Fi to hand or any other bits and pieces. But as our friends from Vodafone assure us, their network is absolutely everywhere, so if we can rely on that, that's great. We can communicate wherever we are in the country. Now, the good thing about the Mbed microcontroller is we have a USB host interface, which means all of the consumer devices that have USB connectivity become applicable to our microcontroller, our humble microcontroller. Now, over the last 6 months, we've actually been putting a lot of work of and effort and blood, sweat and tears into actually making what is essentially a off-the-shelf commercial USB 3G dongle work with this microcontroller. So from a hardware point of view, it's really easy. It's just 4 wires, it's just USB. The software story isn't quite so simple. You need a TCP IP stack in there, you need a USB host controller, you need an RTOS, and of course a bunch of other stuff. I say it like that because I'm a hardware guy. And this is really what we're here to kind of promote this weekend. So the library that we've actually generated for this is going to be going out over the next week or so for people to test. And rather than pretending that it just works, I'm going to build some of the programs and give you an idea of hopefully how it works. So the first test I'm going to do with my USB dongle is to just send a random text message. Now, a lot of this looks sort of horrible and complicated, but it really isn't. The only part of this test program, because our tools are online, I should point out that it's very easy for us to share code. So for instance, if I go to that's not the page, sorry. Yeah, so I've basically imported this program from a Subversion URL that's hosted on our page, so we can get updates and understand when there's been new revisions to the software and so on. So in some ways it really is a sort of professional software development tool. So this program is fairly simple. It's just going to send a simple SMS that says hello from Mbed. As before, all I need to do is compile it, download it to my USB dongle. Actually, rather than send it to my phone, does anyone else want a text message spammed to them? Okay, so otherwise I could just lie and say, oh yeah, I've just got a text message, haven't I?
Send it to me.
Yeah, okay, so if you want to read out your phone number.
7715.
Sorry, 7
077
7715
204
204.
204 331. No, sorry. No, not double 204, just 204.
Like that.
That'll do, yeah.
I'm fairly sure it has to be exactly right, but yeah, as long as you're happy with that, then I'm happy with that. So hopefully it should just be a case of compiling that, downloading that. I'll go back to our humble serial terminal. Because we're doing some heavier, dutier stuff, we need a bigger ball break for this, I'm afraid. So as our Mbed boots, it starts bringing up all the different bits and pieces. So initially the dongle comes up as a CD-ROM, which is where it contains its drivers. We send it the magic packet, which switches it to a USB COM port, essentially. And then we just fire AT commands at it until it registers. We've been having all sorts of registration fun and games today. Looks like we've been spared that, potentially. Oh no, we're still waiting to register. And we've hopefully sent an SMS, so our gentleman at the back can confirm that he's got something.
Yeah.
So awesome. I was going to actually live code this, but I bottled it in the end, quite frankly. Right, So that's proving that we can actually send SMSs from what is essentially an off-the-shelf Vodafone dongle and a cheap microcontroller. And just to prove they are actually commercially off-the-shelf and easy to get hold of, we did actually blow, I think, four of them up between us yesterday afternoon. So this morning was spent frantically driving around Tesco's refreshing our stock. So if we take our example of the commercial greenhouse that we don't want to kill all our plants in. In fact, I'll go back to my test and borrow that gentleman's phone number. You do realise you're going to be spammed all night now. Okay. So what was the big ugly program before, because it was the test program, hopefully boils down to something quite simple. We're going to send a quick test message to say we're a temperature alerter, and now we're going to spin in this loop, just reading the temperature off of our sensor, and if it hits 27 degrees, hopefully you'll get a text message saying it's done exactly that. So if we compile that. Come back to our Terra term. Hopefully the dongle's already registered with the network, so this should be quite a bit quicker. So it's nowhere near hot enough in here at the moment. I'm not going to kill any plants like this. So hopefully the joy of being stared at by a whole bunch of people will get my body temperature up high enough to trigger it. This is right, you're going to have to stare harder. You've got to go this way. This could take a while. Yeah, go for it. Has everyone got a hot cup of coffee in the audience? No?
Cold cup of coffee.
Ah, screw this. Okay, I'll tell you what we'll do. We'll go back and we'll change that threshold. The threshold was working an absolute treat earlier, but we'll change it to 25. Maybe that'll be the point at which all our plants die now. So,
change your if state change.
Oh, hang on. This is what I like about doing coding examples in front of a techie audience. There's nowhere to hide. But thank you for spotting. So hopefully, hands a bit warm. So you should have been spammed again by now.
Yep.
Okay. Let's see what we can do.
Oh yeah. 25.5.
Close enough. I blame that on rounding or something. So yeah, so in a real application you can now go and tend to your tomatoes or whatever it is you need to do. Okay, so SMSs are all very well and good, but I've read something in the newspaper a couple of months ago about called the Internet of Things or something. Apparently some company said it's going to be big.
Government said it's going to be big.
Yes, oh yeah, and they're always right. So
Yeah.
And Cisco said something about it as well, but yeah, I'm not sure they know what they're talking about. So is anyone here from Cisco? Or I say shocking things like that? Okay. So I'm going to go back to my slides for a bit. There'll be not that one. So we've talked about this is what I want to talk about, because I think this has got something to do with the Internet of Things. So HTML5, which you're probably all more familiar with than I am, to be quite honest, has introduced a couple of new features. And one of the best things is full duplex communication over a single TCP socket in the guise of WebSockets or secure WebSockets. So currently websites like, well actually all of them, including embed.org, have to do horrible polling, AJAX, asynchronous nastiness, and WebSockets really hopes to sort of take that away really and make the world a lovely place. So the implementation is just like HTTP, so it does a request and then it asks for an upgrade to be a WebSocket, and then from there on you can do bidirectional communication. If anyone knows more about WebSockets than I, then yeah, please feel free to tell everyone at the end. Sorry? Ah, someone else, okay. So we decided that this would actually be quite an interesting interface to expose, and we're now going to run a quick demo showing how you might stream live data. So if you didn't want to just rely on getting a text message when your tomatoes are about to cook, you might want to monitor in real time just how hot they are if you've got that much time on your hands. So we go back to our compiler, and it just so happens that I have a program here, which again, using the USB 3G dongle, instead of making a connection, an AT command connection and talking text messages, we now make a WebSocket connection here, which gives us the context we need to communicate. And then we're just going to spin in a loop every 3 seconds or so, sprinting a JSON string based on some numbers that we are pulling out of the temperature sensor. Unfortunately, the scaling on the graph is a bit weird, and I didn't have time to fix it, so instead I've fudged some numbers in there. It's an audience of engineers, you know what fudging's all about, so I'm not going to apologise. So now I'm going to compile this and run that on our embed. If we go back to and trusty old Terraterm, so it's going through its usual routine of doing bits and pieces, but this time it's going to open up a PPP connection, and I'm now streaming over WebSockets some real-time sensor data. Minus 45 doesn't look quite right, in my opinion, but at least I can change it, which is nice. So that's one part of the story. Of course, the next part of the story is, where's that data actually going? So on embed.org, we've whipped up a quick Tornado server, and here we're just streaming data into a channel. Now, any other client that's capable of supporting WebSockets can subscribe to that channel and start pulling out data. So that's exactly what I should do. So hopefully I should be getting a real-time graph here. Yeah, that doesn't look right, does it? I'm going to wiggle the wires a bit. I blame it on the wires. It's always the wires. So what you should have been seeing there is a lovely graph changing as oh, hang on. Yeah, maybe we're back in business. Ah, screw that. Let's do something else. So I'm going to do a bit of audience participation now. Especially, is there any C programmers in the audience? Excellent. Okay, so how do I do RAND exactly? Because I don't want to open up Google. Do I just do RAND?
And then a percent of the...
Oh, okay, so if I do...
No, afterwards, yeah.
Percent... Actually, let's see what our scale was. 200. So... that looked like it might work?
Yeah.
Awesome. So hopefully we'll do exactly the same again, but this time we're going to start getting some random jazz in there. Obviously, while it's busy connecting to the network and doing its thing, it goes for a bit.
It's like reminding you of random numbers. Could still be random.
It's always coming up with the same random number. Okay, that's
Guaranteed random. There we go.
there we go. So that's doing something randomish. So has anyone got a smartphone in the audience? That's probably the sort of audience where you're likely to have. If you want to go to that URL and just prove that you can actually see these numbers at the same time, it's tools.embed.org/IoT/ apparently the training slash is quite important. If anyone wants to do that and confirm that I'm not making this up. So I'm waiting for the rapturous.
Wi-Fi delays.
Sorry?
Wi-Fi delays. Give it a minute.
It's all Tesla's fault.
Yeah.
Loading.
The network fun and games is particularly ironic at an event called Over the Air, I find. I think I'm going to go to Wirefest next time. Just wires. Right, okay, well. Yeah.
No.
So you're basically seeing the same thing?
No, you're not scanning anything. You've got
Who's
to
seen
sign in.
this?
Oh, yeah, you have to hit, sorry, you have to click show all at the top. Sorry, that was the magic step I forgot to... quite an important magic step, as it turns out. Yay! Right, okay, so hopefully you would have seen how with just a few quid's worth of hardware and off-the-shelf USB dongle we can do sort of real-time streaming of data, and it's not particularly scary coding either. It's quite straightforward. With a little help from the audience you can get it right, it's not too difficult.
Can you see LEDs coming on and off, etc., or is it just?
Hell yeah.
I mean from the PC side over the internet.
So
is there some way to represent the LEDs coming on and off, or do you just see the log? You know, you've been showing the log where it says.
Oh, you mean
the value?
That log?
Is there some pictorial representation that's given out the same as the graph?
There's not, but that's because I haven't coded it. I mean,
right,
the hard bit is getting the bi-directional communication. we kind of have that now, so it's just a case of typing rather
but
than.
If you had instrumentation that was switches, could you actually represent them on the same page as sort of as?
Yeah, sure. So that page that we have is it's been bodged and reused. It wasn't originally an environment sensor, so it's measuring light, temperature, air pressure, barometric air pressure, and all other bits and pieces. And of course, you can do other things like have buttons on this page which control back to the hardware as well. So it is a bi-directional link. It comes down to your own creativity and your ability to type C code, really.
Right, so you can feed values back.
Yeah, if you wish. It's like I say, the hard bit is establishing the channel, but that's been taken care of. So it really does come down to your imagination and what you want to do with it.
I'll take a question from here for you.
Oh yeah, go for it.
Can you give me a Galaxy S3?
No. Next.
How much does an embed cost?
£39. Available at all good retailers.
Club Digi, don't know what that means. Could it be improved, and are there plans for own?
Or?
It says own.
Own. Well, if you want to be anonymous, you might have to quickly explain what own is. Yeah. Anyone?
What's up with this guy in tomatoes?
Tomatoes. What are tomatoes? Okay.
Tomatoes.
Oh, tomato. Oh,
tomatoes.
I don't know where that come from, actually.
It's a new line.
Yeah, you say tomatoes, I say. I don't know. I don't have a particular fetish for tomatoes. It's just, I've been challenged to build a greenhouse thing by someone a long time ago because their tomatoes die regularly. I don't see it as my problem, but there we go.
There's been some people trying to hack it seems as well.
What?
Sending escape characters to try and...
Yeah, are there any magic kill characters for that?
Just look at the manual.
Okay. Yeah, it's only a 3-metre roll, so if you can find the line feed command, just keep sending that, that'd be awesome. Okay, getting back on topic, I suppose. So the summary really is that we think that there's a massive opportunity just for microcontrollers in general because of their power capability and cost. Embed is really there to help people experiment with this, prototype, try out new technologies and ideas, and just an experimenting tool really. For the Vodafone part of things, we think that 3G connectivity could bring quite a lot to this, to this area. People building things that sort of connected. If you have SMS connectivity, they could be anywhere in the world, and you can still communicate with them. Within the bounds of the UK for now, you can have this lovely bi-directional communication with them. The important thing is it's all off of readily available hardware. So, as we said, the embed's available from all good stockists, and it's relatively cheap. As I found out this morning, you can even buy the dongles from Tesco. So it's really about accessibility and getting this sort of technology into people's hands. So I would, just plug in again while we're here. If anyone fancies beta testing this, then go to the subtle URL. Questions I think we've already done, unless anyone wants to.
There's a couple more came through. So one was, great demo. Does this work for all 3G dongles? The answer is at the moment no, because it's like a private beta. But eventually, the intention is that this code is going to be open source once it's been tested and out of private beta. So you can modify it, to work with anything.
Two questions. The IDE is all on the web. I'm sorry if I missed it. Can you also have an offline compiler if you want?
Yes, absolutely. So we took a lot of heat in the early days about online compilation only. It seems that a disproportionate amount of people want to compile whilst at the top of a mountain or on a plane. We never predicted that one. So what we did is we added the ability to, say, right-click and export a program. And you can either export it to something like Microvision, which is a fairly industry standard tool, CodeRed, which is another one that's basically Eclipse plus GCC, or just get tarballs for these two tool chains. So there's no, we're not trying to lock anyone into any particular platform.
And can it run off a battery as well, or does it have to be plugged into the mains?
No, you can run it off a battery. Obviously, the size of your battery and how well you've power optimised your code depends on how long for. We haven't put too much effort into making this as optimal as possible because it's a prototyping tool. But yeah, with an appropriate battery, you can probably have a month's worth of runtime.
If you want to come over, we've got some like batteries and stuff over in our hacking stations, and nobody's actually powered up the battery yet. So if you want to be the first to do it, you put it together.
Yeah, I should also say we're in the bar area of the mansion house. We've got a bunch of laptops, a bunch of dongles, a bunch of embeds, and a bunch of stuff. So if you've got anything that you want to connect to the internet, then feel free. We're going to be here until silly o'clock, so yeah, come over and join in. So, will it run off 3 volts? No. So USB is 5 volts only. So the embed will run off of like 3.3 volts, but it's the dongle in this case. Okay, at that point I'll hand over to Ashley, who I think wants to talk to you about some other bits and pieces.
I'll just read these final 2 questions.
Oh,
Someone
okay.
said, will it rain? Yes, it will rain. So,
Yeah, eventually.
will there be dessert wine again? That's a good one. Who likes dessert wine? I can see there's Carlsberg, red wine Australia, Oyster Bay New Zealand, Chardonnay, Brains Beers, Witchwood Breweries, Wadwood, Marston's, Bulmers, and Bacchus.
Awesome. Okay.
Continue dessert wine.
I'm done for the day, so I'm going to go out there.
Save some for us. Okay, so I'm going to do a bit more of a deep dive into the code. I'm a bit worried that only one person put their hand up as a C programmer, so because there's quite a lot of C code here. But so when I think we signed up for OTA just a couple of weeks ago, and so we thought, oh, quick, we need some demos. So these were really done like in the last couple of weeks while we're doing all our other work. So it's a good example of what you can do, rapidly with these things.
Be honest, they were all done this morning, really, weren't they?
Yeah. Okay. Yeah. So one of them I'm still actually working on because I'm like tweaking the driver, but yeah, you can come over and sit. Okay, so I'm just going to introduce the dongle API, what's there at the moment, and then talk about this question mark thing, show the code for that, and then go through this other application called the VGA node. Okay, so here's the header file with some stuff taken out. This is as it stands at the moment. Now what we want is to get feedback off people to know what people want in this library. Does it mean it's being funded, the development is being funded. So if you want some like professional stuff in there, not that amateurs can't produce good stuff. If you want some good stuff in there at our expense, then tell us and we'll put it in there. Okay, so obviously you've got the constructor, right? I'll skip over that one. Now, the other thing in there is to connect. Now this gets a PDB context from the network and gives you an IP. So in mobile networks, you don't have an IP all the time. You have to establish a PDB context and then get an IP because these things are constantly cycling. They're being torn down and put back up all the time. So at the moment, you have to specify the APN, the username, and the password. And if you saw in that other demo, the one for our contract sims was internet, web, and web. That's all public information. Now, Nicholas, who's sitting over there, he worked on the dongle drivers for Linux, and we've got some tricks so you won't actually have to do that when we get to the release version. It'll automatically detect the APN. But maybe you want to connect to your own private APN. So once you've connected, then you might be wondering, hang on, I can't see any kind of IP stuff. But this is because with the embed library, you just use 4.4 BSD sockets. So that's all abstracted away. So you could change it for Ethernet, for example, and you wouldn't have to change the rest of your code because you're just using sockets. You've got send short message, takes the number and the message, pretty self-explanatory. Get short message takes a pointer to where you want to store the number, a pointer to where you want to store the message, and the length, so you don't overflow your buffers. And then you can see how many short messages have been received by providing a pointer to your size T. Now, the way this works at the moment is just there's a FIFO queue, the messages come in, and you read them off one at a time, with the get SN call. Of course, maybe you want to have some kind of managing of the SN file kind of mailbox in a different way. I don't know why you would, but if you want that, tell us, and we can put it in there. Send USSD. You might not be aware of USSD, but it stands for Unstructured Supplementary Service Data. and that is a connection-oriented protocol which was designed for GSM for doing things like getting your number. Like if you do a *#100 hash, that retrieves your number or the MSI-SDN number of the SIM from the network. And but there's potentially loads of different cool things you could do there if you had your own APN, or if you could change things around. If you could get access to the HLI. But anyway, so you can do your SSDs, you can check, top up how much credit's left on the SIM and so on like that. This gives you access to the raw AT commands interface. I requested that personally because I'm writing a little console, so you can use like GNU Screen or whatever you want, just to log in and mess around with the modem, send AT commands and stuff like that. So yeah, that's the library as it stands. But please, if you have any kind of ideas about what should be in a dongle library for an embedded controller, tell us, we can get it in there.
Can you get signal information back, like signal strength, and whether it's on 2G or 3G?
Yeah, that's a perfect example of what probably should be in there. So you can get RSRPs, so receive signal strength, receive signal reference powers from like all the cells that the cell you're attached to, and you maintain a neighbour list in GSM. So all those neighbours, you could get the RSRPs. You could also get like the RSSI, the received signal strength indicator, which is just like a measure of signal strength. So yeah, it'd be cool to have those because as standard, it's a typical thing, isn't it, to see your signal strength.
Cell broadcast as well, or would that be out of spec?
Yeah, I don't know about broadcast, but because I don't know anyone that actually uses cell broadcast.
No,
but
it's nice to have those.
Yeah.
Do you use a translator based on where the phone was registered?
Translator?
Yeah, like based on where the phone was registered. If it's a +44, it's English, or if it's
Oh, what, to determine location would be a good call to make. That'd be a good call to make over USSD, in my opinion, because then you wouldn't have to establish a P2P context to get an IP. You can do that over even when you don't have GPRS, right? Which is pretty crazy. But yeah, so location I think would be a good one. Okay, so I'm going to talk through the question mark, which is up there, which as you see does actually work. We were messing around with it to begin with because as we were carrying it over, it ripped out the barrel jack which powers it. So we had to quickly sort of do Mission Impossible when he's biting the wires. Kind of do that and plug it back in. But anyway, it's working now. So I saw this. There's a thermal printer. This is an printer which is I think sold and marketed by Adafruit, and they wrote a driver for it for the Arduino. And I was at a meetup, Internet of Things 7, a couple of months ago, and someone had written a library for it to print out pictures. But there's a whole bunch of people using that thermal printer, receipt printer, like for doing things like there's the Berg Little printer, for example. They don't use that one, but they use another thermal printer. But it's a good demo because it fits on one page. But if you think about it, the problems we've had with Wi-Fi here, and in some circumstances where you don't have Wi-Fi, you might want to have some kind of ad hoc feedback point where you can just deploy it, especially perhaps in developing countries. So anyway, it's more of a proof of concept rather than an actual product or something like that. So yeah, the thermal printer is popular using Ethernet. There's cool stuff like in a cigar box. So this is a quick question mark, thermal printer with dongle SMS. How's it laid out? You've got your embed microcontroller there. I'm taking the 5 volt on the ground to power it. Actually, you don't need that line because they're all tied together, but I only learned that today. And then we've got this Adafruit thermal printer, which just takes a ground, 5 volts in, and then it's just got a TTL serial interface. Now, the driver for this is extremely simple to write because, well, guess what happens when you send ASCII characters to it? Yeah, it prints them out, right? So it's not exactly rocket science. Then we've got a dongle plugged in here as well, which is on the USB D- and D+, and it takes its 5 volt and ground from the same rail. So everything's like on a common ground. So that's how it's laid out, and this is the code for it, which fits on one page. So we start just by declaring the modem. Of course, in C++, that actually calls the default constructor as well. So that's actually already constructed. But yeah. Then there's the Adafruit thermal printer library, and I've said it's on pins 13 and 14, which are the these two serial pins here. Now this Adafruit library was written for the Arduino, so I quickly ported it to the embed, and yeah, it didn't require many changes, so that was useful. And then you call printer begin to start the printer. I've got some memory allocated here to store the receiving number in and to store the message in. So if you send more than 256 characters, it's not going to go through. I don't know. I think that's the length of an SMS. I can't actually remember why I chose that number. And then also somewhere to store the callback from get SN count. So then, yeah, when it fires up, it sends me a message saying that it's online. So that's my number, which is publicly available. So there's nothing new there. And then we go into a loop. Now in this loop, it just checks to see if the modem has any short messages. So, well, actually, this is just loading the number of short messages into this variable. This is kind of this C syntax that you see where they're doing that action and the comparison in the same step, which looks a bit obfuscated, but they do it all the time. So, you know, it's just something to get used to. So once we know how many SMSs there are, is it greater than 0? Yes, it's greater than 0. We've got an SMS. Get the SMS, load it into the number buffer and the message buffer. So then, if that was okay, so we've done that, and also if that was okay, then simply print the message buffer and feed it. So, you know, send some new lines so that, because where the thermal head is, it's like underneath the lip, so you need to feed it a bit to be able to see the message when it comes up. And then we just call a thread wait statement at the bottom, which allows the dongle and all the other threads that are running to operate. Because this is running on a real-time operating system on the mbed microcontroller, which is multi-threaded. You need that if you've ever done stuff on Arduino, what you end up doing is having like one big loop where you kind of are emulating the threading yourself. So it's really good to have threading. I'm sure someone will write one for the Arduino, but you know. Yeah, so then we go back around again. And that's all it is. So it's very, very simple. It's just one sort of page of code and allows you to, you know, write something like that. I think anyone can do this. It's very straightforward. So the second application is called VGA node. And what this is a mbed microcontroller, a dongle, and a VGA camera. So this takes pictures at the breathtaking resolution of 640 by 480, and then it stores the image on there, and then you can retrieve that image over the serial interface. I was going to use a USB camera, but at the moment you can only use one USB thing at a time. That's going to change in the future. But anyway, so that's what I use. It's off the shelf. It's easy to get hold of. Here's the circuit diagram. You've got the mbed again. Then you've got this camera, which just takes 5-volt ground and these transmit and receive. We'll just connect it to the same pins again, and the dongle again. So it's actually quite a straightforward application. But there's 3 parts to it. There's the camera driver, the client code, and the server code. So starting with the camera driver, there were a couple already written, but I wanted to write my own just for no reason. So how do you do this? Well, you look at the manual. First of all, you need to set up a serial connection to the camera. So this is establishing the serial connection. And then, how do we actually control the camera? Well, it's quite simple. You send serial commands over the serial interface to the camera, and expect certain results to come back. So for reset, you send that sequence, and then it will send that back if it's reset the camera correctly. Okay, so the kind of process overview for the driver, the way I wrote it, is I just defined all the sequences in C and their lengths. Then you've got to have something to push the sequences to the camera, and you've got to have something for wait for the response. Now, it's not that simple to do when you've got a blocking request in a multi-threaded environment, because the mbed hardware buffer is only 16 bytes. So this is a problem I found out today, in fact, where you have to be very careful. So I think I'm going to have to rewrite this as an interrupt-driven driver instead. But anyway, you'd still use the same kind of things. And then, so to actually use this, I would put this sequence to the camera, and then wait for the response. And that wait for sends a boolean saying yes or no, it's successful or not. And then that's how I would like reset the camera, for example. To actually take a picture and get it onto the embed is a little bit more involved. Now I've said here, if you can understand the docs, because this documentation can sometimes be quite hairy when you buy these like cheap things that you just want to get up and running. So what do? We send this command to take a picture over the serial interface. It returns this. Great. Now read the file size. Oh, but wait a minute. Where's the file size? Oh, that's right. Looking somewhere else in the documentation. Yeah. So this flowchart is from the documentation, but it's obviously conflicted because it says here that this is actually what is returned, not that. And the most significant byte and then least significant byte file size are sent at the end. So you have to load those in, and you get the file size. Now that you know your file size, you want to read the file off the camera, retrieve the file. So you send the memory address and the number of bytes to read, and then you increment the memory address, and say you've got a fixed buffer of, let's say, 16 bytes, and then you'll send the memory address of 0 and 16 bytes to read. Then of course you send the memory address of 16 and 16 bytes to read until you've read everything. And then once you've read it, what you do with it is up to you. So I was sending it over a socket to a Node.js server. You might want to dump it to a file or do something else. I think I'm going to change the code later. So if you come into our hacking area later, I'm going to change it so it writes it to disk and then sends it to the Node.js server just to make it a bit more robust so it can have retries and so on. Right, so once you've done that, you kind of iterate around that process of incrementing the memory address. Again, this documentation is kind of bizarre because this is supposed to be a conditional flow operator and a flow diagram. So it should go to the right, but what's going on there. And they're saying to look for end of file, but I wouldn't do it like that because you know exactly how many bytes you're reading. So it's better just to read that many bytes rather than look for some sequence. But yeah, you get the point though. You iterate round until you've read the whole file. Then you send stop taking pictures. So that's kind of the driver in essence. Now to the client code, there's quite a lot of code, so I've just broken it down into blocks rather than the actual code. First of all, you set up the camera, and then you set up the modem and connect. That's the pay-as-you-go APN. And then you establish a socket to server. So like I said before, you're just using BSD 4.4 socket, which is brilliant because every C programmer knows that. And if you're on any Linux system, you can just type man socket, and you're going to be able to read the manual. You don't have to you don't even have to be online. And then, so I've not shown all the steps there, but you can do stuff like resolve, DNS, and so on. And then you do a socket connect. It gives you a file descriptor for that socket that's active. Then once you've done that, once you've got your socket up, you can just send stuff to it. So it's a bidirectional pipe, so you can just send strings to it, byte sequences, like using that, or you can receive stuff by providing a buffer to receive it into and the length of the buffer and so on, so you don't have overruns. So that's how you communicate over a socket. So in the body of the client code, so we've set up the socket, got the camera working, and set up the modem. I'm creating a buffer, and then taking a picture. Then I go into a loop where I read one chunk from the camera, push that chunk to the server. So this is where it's a bit weird because I'm pushing it in real time, whereas later on I'm going to change it. And then you increment the pointers, like the start address and so on, until that process is complete. And by the end of it, you should have the picture up on the server. Close sockets in the camera, and then you're done. So that's the client. It's all about the server code. I did it in Node.js just because everyone was talking about Node.js, and I wanted to see if it really was as easy as everyone claims. I think the answer is yes, it is as easy as everyone claims. So you could, first of all, you declare these structures. I'm using net and the file system, and I've got a password called insecure there. And then you create a server. So this is the famous Node.js one-line server creation on a given port. Then in Node.js you have to define, it's all event-driven, so you define an event. One of them is a connection, so when somebody connects to that server, it fires off a connection event, and as the second argument to this function, which is a bit of a weird thing, you have the actual, you actually define the function, and you receive a socket object. So then that socket object is scoped to that connection. So we've got a socket object, which is a socket object sent by the client after it's taken the picture. Yeah, that's just setting the file stream to null to begin with. Now, the cool thing about this, I think about Node.js, is now that you've scoped to that connection, you can then define events on that socket. So here, I'm saying every time you receive data, call this event. And this event takes a buffer or a string, in this case a buffer, and then you've got to process it. But the first time the person wants to connect, I've got this kind of crappy security here where I expect the first bytes to be a password. So I'm using this if socket bytes ready equals 0, so if it's the first time someone's connected to this socket, then check the password. Now, I actually saw on the mailing list that they're thinking about getting rid of that bytes read, but you could just do it with a counter or something, right? Now, yeah, check the password. If it's wrong, end the socket. You probably want to use a bit more secure authentication and integrity checking if you're doing this for anything serious. And then if the password is correct, you create the write stream picture, which is on the server, and the server is running with permissions, whoever instantiated the instance, whoever called node on it. And then, yeah, I'm also defining if there's an error on the file stream, then set it to null and close the socket away. So that was all the first time the data came to the socket. Check the password, create the file, and then the rest of the time data comes to the socket. We just write the buffer that's received. So that's quite straightforward, and I'm relying on the client to terminate the connection. This is just a prototype, right? There's one bit missing here, which is also I've got if the socket receives a close event, then if the file stream's not null, then close that away as well, just to clean up. Okay, so that's the server code. So just to say what we've gone over, we looked at the API in the present incarnation, looked at a simple SMS printer example, and then looked at the JPEG camera, which used Unix sockets. And that's it. So